Hello everyone, welcome back. In this video we are going to look at this problem from LeetCode, and the name of the problem is number of provinces. So firstly we'll go through the problem statement. According to the problem statement, there are n cities and some of them are connected while some of them will not be connected. So if there is a city A which is connected directly with city B, and let's say city B is connected to city C, then we can say that city A is indirectly connected to city C, right? And it is given that a province is a group of directly or indirectly connected cities. So basically, if there is a cluster of connected cities, then we call it a province. And we'll be given an n cross n matrix called is connected, where if city I and j are connected to each other, then in this matrix that particular cell will contain 1, and if city I and city j are not connected, then the cell will contain 0. Okay, we need to return the total number of provinces. So this was the problem statement. Now let's see the approach to solve this problem. So let us consider this case where we are having 5 cities starting from 0 till n minus 1. If we consider that each city is a vertex, and in between two connected cities we have an edge which represents the link, so what we get is we get a graph here. Now in order to find the number of provinces, basically we can reduce this problem down to finding the number of components, right, in our graph. In the problem statement it is given that we'll be given a matrix. So as we all know that there are two common ways to represent a graph. First way is to represent it using an adjacency matrix, and the other way is to represent it using an adjacency list. So in this problem it was mentioned that we'll be given a matrix. If there is a connection between two cities I and j, then in that matrix that particular cell will contain a 1, right? So if I talk about this particular graph, its adjacency matrix would look something like this. This matrix will be given to us. Now in order to find the number of provinces, it basically means we need to identify the number of components in our graph, right? Here you can see that there are two components in our graph, but to identify them we are going to use DFS algorithm. So DFS, which basically stands for depth first search, is a graph traversing algorithm. We start from a particular node and then we explore all the nodes that can be reached through this node, and at a time we explore only a particular path. We keep going through that path as long as we keep finding new nodes in that path. The moment we stop finding new vertices in a particular path, we go back to the previous nodes, and from there we explore other branches from that particular node. So this is how DFS traversal works, right? So we can use this algorithm in this problem. We will keep track of the visited nodes or visited cities in this case, and we will start our DFS from an unvisited city, and then we will visit all the other cities that are directly or indirectly connected to this particular city. That entire cluster will constitute a component, and in this problem we call it a province. So we will keep a counter for the total number of provinces that we come across, and using a visited array we can execute our DFS algorithm in this graph, and at the end we can return the number of provinces that we found. Let's quickly move to the coding section. So I will copy this code and we will dry run this code on our example. So it is a simple code. Firstly, I have initialized a count variable for counting the total number of provinces. Then we'll be given an n cross n matrix called is connected. So I am finding the number of cities, which will be our n. Then I have initialized a visited array for the n cities, and initially all the n elements will be 0 for our n cities, which means that we have not visited the n cities yet. Then let me just refactor this code. Then this is our DFS function. We will come to this in a while. So what I am doing is we will iterate through the n cities one by one, and if ith city is not visited, we are starting a DFS traversal from that city and we are incrementing our count, because whenever we come across an unvisited city, it means that we are exploring an unvisited province. So starting from that city, we will mark all the other connected cities of that province as visited. So that's why we are calling this DFS function from this current city. Now when this DFS function will be called, so in this function, firstly what we are doing is we are marking this city as visited, and then for NBR in range n, it means that we are checking one by one, we are checking all the n cities and we are finding for neighbors of this current city. So if in our is connected matrix, if the cell city comma NBR is marked as 1, it means that the two cities are connected to each other. And also we are checking if this NBR city is unvisited. If it is unvisited, then we are calling another DFS function on this city, and then again then that particular city will be marked as visited, and then we are going to find neighbors of that city. So this is how our DFS function works. It is a very basic implementation of DFS. After all this, we are simply returning count. So total number of provinces that we found in this example was 2, and at the end we will return 2. So I hope it was clear. You can go through this code if you want, and if you submit this code, it will surely get accepted. So that's all for this video. Thank you.